lesson Thursday 131. Taking a look at radicals, some more focus yesterday and today on rational exponents. We're talking about using properties of exponents. We mentioned them yesterday. They are listed here. Again today, product of powers or exponents. You multiply, you add. Power to a power, multiply. Power of a product. So if you have more than one thing being raised to an exponent, each thing gets raised to that exponent. Negative exponents, that's reciprocal. We talked about that yesterday. Zero exponent, anything raised to the zero is 1. Quotient, when you're dividing, you subtract exponents. Power of a quotient, again, this is similar to the one up here, that if you have more than one thing being raised to that power, each individual element gets raised to the power. And we see some examples here. For instance, I have 5 to the 1/2 and 5 to the 3/2. We're multiplying, so I'm going to add. 1/2 plus 3/2 is 2, 5 squared is 25. Power to a power, we multiply. 5/2 times 2 is 5, 3 to the 5th is 243. 16 times 9 to the 1/2. I'm going to use the product in reverse here, opposite of what we might do in some things. But anyways, this one, we're just raising each of these to that power. 16 gets raised to the 1/2, 9 to the 1/2. Wait a second, 1/2, what does that mean? This is where the property from yesterday comes in. If I'm raising 16 to the 1/2 power, the denominator is the index. That means it's the second root of 16 to the first. So one thing you need to get used to, when you raise something to a 1/2 power, that's the same thing as saying take the square root. When you raise something to the 1/3 power, that's the same thing as saying the cubed root. Something to the 1/4 power is the same thing as saying the 4th root. So when I see raised to the 1/2 power, I'm thinking square root of 16 is 4, 9 to the 1/2 power, square root of 9 is 3, 4 times 3 is 12. Negative exponent, 36 to the negative 1/2. Negative exponent, you do the reciprocal. So 1 over that. And then 36 to the 1/2, again, 1/2 power means take the square root. 36, square root of 36 is 6, so 1/6. Anything to the 0 is 1, whatever. When I divide, I subtract. 5/2 minus 1/2 is 2, 4 squared is 16. And then this one, again, if there's more than one element being raised to an exponent, each element gets that exponent. So 27 to the 1/3, 64 to the 1/3. 27 to the 1/3. Again, 1/3 means cubed root from our property yesterday. The denominator is the index. So that's the cubed root of 27 is 3, cubed root of 64 is 4, and 3/4 is the answer. Okay. Just a little bit of practice with the rules of exponents. Let's match these properties. First of all, a to the negative 2. That would be 1 over a squared. That's the negative exponent rule. ab to the 4th. A to the 4th, b to the 4th. Okay? That's that one where it's kind of like taking each exponent and putting it in. It's called the power of a product. Okay? A to the 3rd to the 4th. Power to a power, we multiply. A to the 12th. Power of a power. We're multiplying, you add exponents. Product of powers. A to the 3rd, b to the 3rd. Each one gets its own exponent. So we're raising each of these to the 3rd separately. It's power of a quotient. When you divide, you subtract. Quotient of powers. And anything to 0 is 1, 0 exponent. So if that helps you clean up some of the rules of exponents. I do have another example here of just rules of exponents in general. I know some people struggle with that. Some people do struggle with that. So what we're looking at is an example like this. What's going on here? A lot of different things. We're going to use more than one rule. We're going to use the power rule. I'm going to take 2 to the 3rd, raised to the fifth, to y squared raised to the fifth. Power to power, you multiply. 3 times 5, 2 times 5. So I get 2 to the 15th and y to the 10th. Now I'm going to use the quotient rule. Both of these are base 2. I'm dividing, so I'm going to subtract those exponents. 15 minus 10 is 2 to the 5th. Subtract these exponents. Y is negative 6 is its exponent. 2 to the 5th is 32, and a negative exponent means reciprocal, which means it gets put in the denominator. So again, just a little bit of algebra 1 review to help you clean that up. Let's take a look at our example. Both have the same base. That's important. These have the same base number. The radicand is 7. So when you multiply, you add exponents. 3/4. 1/4 plus a half. Here the bases are different. I can't combine those. What I can do is raise each of these to the second power. 6 to the 1/2 raised to the second. 4 to the 1/3 also raised to the second. Power to a power, you multiply. 1/2 times 2 is 6 to the first. 1/3 times 2 is 2/3. So 6 to the first, or 6, times 4 to the 2/3. Nothing else I can do to simplify. Once again, the bases are different. The radicands are different. So I'm going to raise a power to a power. They're going to multiply. 5 times negative 1/5 is going to become negative 1. 5 times negative 1/5, negative 1. Now what they're doing is they're saying, well, these have the same exponents. Watch this trick. If they have the same exponent, I can put their radicands together under the same exponent. 4 times 3 is 12 to the 5th. So look at it. They both have the same exponent of 5. So we take 4 and 3 multiplied together, 12 to the 5th. Now I do a power to a power. 5 times 1/5 is negative 1. Negative exponent, reciprocal. Here we're dividing. This is an unseen 1. So I'm going to subtract. 1 minus 1/3 is 2/3. And again, these have different bases. However, they do have the same exponent. So I'm going to pull those two numbers together and raise them both to the 1/3 power. 42 divided by 6 is 7 to the 1/3 power. Power to power, you multiply 7 to the 2/3. 1/3 times 2 is 2/3. Okay? Only way to get good at these is practice, practice, practice. Go ahead and try that home.